Assalamualaikum YouTube viewers. This is the first video of a series of videos in which I am going to explain different tools used in computational chemistry like ab initio method, density functional theory, molecular dynamics, molecular mechanics and the semi-empirical method. Okay, so today is the first video and in this video I'm just going to give you an introduction. Okay, so in this introduction I'm going to explain what really is computational chemistry. So computational chemistry is a set of techniques for investigating chemical problems on a computer rather than using chemicals. Okay, so what we do in computational chemistry, we just perform experiments on the computer instead of performing in reality in the lab. Okay, so what we do, we just perform our experiment, we just perform the calculation on the computer rather than using chemicals in the lab. Okay, so computational chemistry involves the use of computer instead of the use of the real chemicals. Okay, so the next thing I have is it uses results of the theoretical chemistry incorporated into efficient computer programs to calculate the structure and properties of molecules. So what we do, we just use the results of the theoretical chemistry incorporated into efficient computer programs. Okay, these results are actually incorporated into the computer programs, and using these computer programs we just calculate the structures and properties of the molecules. So this is a basic computational chemistry, that in computational chemistry we use different softwares that using these softwares we can calculate the structures and properties of the molecules, and these softwares are actually based upon the theoretical chemistry. Okay, so the next thing we have is the common computational investigation. So what we commonly do in computational chemistry, so we commonly find the geometries, the molecular geometries, okay, the shapes of the molecule, bond lengths, angles and dihedrals, and the next thing we have the energies of the molecule and transition state. Okay, so by using the computational chemistry we can find the molecular geometry, we can find the energies of the molecule and their transition states. Okay, so the next thing we have is the chemical reactivity, we can find the chemical reactivity. For example, knowing where the electrons are the nucleophilic sites, okay, we can find where they want to go. Okay, and that enables us to predict where various kinds of reagent will attack a molecule. Okay, so the next thing we have is IR, UV and NMR spectra. Using the computational chemistry we can evaluate IR, UV and NMR spectra. These are different type of spectroscopies. Okay, so these are different things that we can compute, that we can calculate using the computational chemistry. Okay, so the next thing we have is quantum mechanics. Actually the computational chemistry is based on the quantum mechanics, so you need to know what really is quantum mechanics. Okay, so quantum mechanics is actually the domain of physics that describes how electrons and protons interact. Okay, so it is the quantum mechanics is actually a domain of the physics that describes the interaction between the protons and the electrons. Okay, so this is the quantum mechanics, and the next thing we have here is the Schrödinger wave equation. Okay, the quantum mechanics is largely based on the Schrödinger wave equation, and this is the time independent form of the Schrödinger wave equation that says h psi is equal to E psi, where h is the Hamiltonian operator and psi is the wave function. Again, E is the energy and psi is the wave function. Okay, so h here is the Hamiltonian operator that is equal to the kinetic energy and potential energy. Okay, so this Hamiltonian operator has this value. Okay, so this is the value of the Hamiltonian operator, and the next thing that we have is the models in the computational chemistry. Okay, the models in the computational chemistry that solve this Schrödinger wave equation are known as the ab initio. Okay, are known as the ab initio. Okay, so this is mainly the realm, this is mainly the kingdom of the quantum chemistry. So our quantum chemistry and the computational chemistry is largely based on the Schrödinger wave equation. So the computational chemistry is not completely based on the Schrödinger equation. It also involves the use of some other theories like that of the Dirac equation, the relativity theory or the quantum electrodynamics. Okay, so computational chemists have a selection of methods. Okay, computational chemists have a selection of methods to perform the computational work. Okay, so the main tools that are available for them can be divided into 5 broad classes, and these main tools are the molecular mechanics, the ab initio calculations, the semi-empirical method, density functional theory and the molecular dynamics. Okay, so these are the 5 main tools, these are the 5 broad classes that the computational chemists use in the computational chemistry. So I am going to explain all of these methods one by one in the next videos. Okay, so the link of each of these video will be given in the description of this video. So today was the introductory video of the computational chemistry, where I have told you about the computational chemistry and led you to the different methods, to the different classes, to the different tools through which the computational chemists form their work. So that was all for this video. Okay, so moving on towards the next video. See you in the next video.